So you know how a lot of algebra questions are based on given 2 points. For example, let's find the distance between these 2 points, or we can also find the slope of the line that connects these 2 points. But there's one kind of question that you don't really see it often. That's the following. First, let me put down a special point right here, and that is, of course, the midpoint. And the midpoint has a nice formula, and that's just going to be the average of the x values, and that's x1 plus x2 over 2, comma, the average of the y values. And what's so good about the midpoint is that this point is equal distance from the 2 given points. But now the question is this the only point that has such property? And the answer for that is of course not, because you can pretty much go up a little bit like this, and you can draw the picture and you'll see it's equal distance from the 2 given points. And in fact, you can do a lot more. You can go up right here a little bit more, and again, it's equal distance from the 2 given points. And the truth is, any point on this line, if you connect all these points together, any point on this line will be equal distance from the 2 given points. And now the question is, you know it, how are we going to get an equation of this line? And I think the reason that you don't really see this question is because the formula to do such thing, it's not so pretty, but you just need high school algebra to do it. So let's have a look real quick. So now, how do we do it? First, we need a point. We have a point already. That's a midpoint. We can use that. Now, we need a slope. The slope of the blue line. Well, how can we do that? Well, here's a fact. In order for this line to happen, this line must be perpendicular to the given line. Assuming the line is not horizontal, the line is not vertical, then you can use the slope formula in the following way. And one way to see why this is perpendicular is just that you can kind of think about folding it to half, right? Just cut this and then fold this to the other side. Then I think that's pretty obvious. But anyway though, assuming that our line in black, it's not horizontal, it's not vertical, then we use the formula m is equal to y2 minus y1 over x2 minus x1. Alright, then the line in blue, which is going to be perpendicular to this line, is just going to be negative reciprocal of this, which is x2 minus x1 on top over y2 minus y1 on the bottom. And now we have the slope and we also have the point. We can use the good old point slope form of the line. Let's use y minus y1 is equal to m times x minus x1. Now, the x1, y1 here, it's meant to be this and that. Right? This and that. And then the slope is that. So let's put down the perpendicular symbol. And we can just draw in everything. And we will get y minus y1, which is this, equals the slope, which we will use that, times x minus x1, which is that. So you can see the formula is huge, but it's not bad at all. And then what we can do next is, perhaps let's take this and distribute it inside, and then move this to the other side, so we get the equation in the y equals mx plus b form. So finally, we'll see y equals, let me work this out first, we get negative x2 minus x1 over y2 minus y1x. And then negative times negative becomes the plus, and then we have this times that. So I will keep it as x2 minus x1 over y2 minus y1 times x1 plus x2 over 2, and then put this to the other side. That's also going to be a plus y1 plus y2 over 2. And that's pretty much it. That's the slope, and this is the y-intercept. And perhaps you can get a common denominator to make it slightly prettier. So we will do that real quick. This stays. But they both have 2, so this right here I need to multiply top and bottom by y minus 1. And have a look. Then we will get 2 times y2 minus y1 for the same denominator. And if you multiply this and that, you can write this as x2 plus x1. Doesn't matter. Multiply it out, we get x2 squared, this is a square, minus x1 squared. It's a difference of 2 squares. Quite cool. And then we add. Remember, we multiply the top and bottom by this. Same idea. This is the same as y2 plus y1. Times that, we get y2 squared minus y1 squared, and then over the same denominator. So there you have it. If you also teach algebra like I do, then maybe you can show your students something like this, which I think is quite cool, and you don't really see this in your algebra textbooks. Yeah, that's it.